So hello all, welcome to my YouTube channel Decoders Day. So today we are going to see properties of XOR gate and XNOR gate. So we have seen what is XOR gate and XNOR gate in our last video. If you have not watched that last video, that is on basics gates, then go through it and come to this video. Okay, but again we are going to see what is XOR gate and XNOR gate, but not we are going to see entire truth table of it. Okay, so what is XOR gate? First we are going to see XOR gate related properties. Okay, XOR gate is nothing but, suppose there are two inputs A and B, is given as A B bar plus A bar B. So this is our XOR gate and this is going to be represented as A XOR B. Okay, so there are some important properties given related to our XOR gate. The first one is, note down this, these are most important properties which are going to be used in our further videos while we are going to solve some problems related to XOR gate and XNOR gate. Okay, so first one is A XOR 0. It is going to be give you A, right? That means when we take any variable XOR with the 0, it is going to give you a buffer. That means it is going to give you result as same variable. It is kind of a buffer. Okay, next one is A XOR 1. It is going to give you A bar. Okay, it means when we take any variable XOR with 1, it is going to give you a inverting buffer. Inverting buffer. Okay, as we have seen in these are both are two important things. Okay, next one, like if you take XOR of A with itself, it is going to give you a result as 0. This is another one property of XOR gate. Next one, if you take XOR with A complement, it is going to give you 1 as a result. Hope these four properties are clear to you all. Next one is, if suppose A and B are two inputs given to the XOR gate, A and B are two inputs given to the XOR gate and C is output. So further this can be written as A XOR C is going to be B. This is also true. If this is true, then this is also going to be true. Again, this can be written as B XOR C is going to be A. Even this is going to be true. Hope this property is going to be clear to you all. Okay. Next one, this is the most important property. Next one is like, if you take A XOR A XOR A XOR A like that for n times, here comes what is the value of n. Suppose if you take XOR of a variable with itself for n times, if n is going to be even, if n is even, then its value is going to be 1. If n is odd, then value is going to be 0. Okay, this is one of the most important property that we are going to be used in our further video. Hope this is clear to you all. Next we are going to move towards related to the XNOR properties. Okay, so properties of XNOR gate. Okay, the equation of XNOR gate is given as y is equal to A bar B bar plus AB. This is the equation of XNOR gate, and this is going to be represented as A XNOR B. Okay, so first property is like A XNOR 0 is going to give you as A bar. It means if you take XNOR of any variable with 0, it is going to produce inverting buffer of that variable. Inverting inverting buffer. Okay. Next property is going to be like A XNOR 1. It is going to produce A. It means if you take XNOR of any variable with 1, it is going to produce a buffer. That means same variable, it is going to give you as a output. It's going to buffer. But next one, if you take A bar as the input and is XNOR it taken with 0, it is going to give you as a output. Okay. Third one is going to be like if A bar is your input and taken XNOR with 1, it is going to produce A bar as its output. Okay. So from this we can say another one. From this we can say if A bar XNOR A is there, it is going to give you result as 0. We can replace the position of 0 and A. Further, this can be written as A XNOR 0 is going to be A bar. Okay, as we have seen in the first video. Okay, first property. Next one is A bar XNOR 1 is going to be give you A bar, right? That means A bar XNOR A bar is going to give you 1. Got? Hope these are the properties clear to you all. Further, if you take a variables XNOR with itself for n times A XNOR A XNOR A XNOR A like that for n times, then the output is going to depends on n only. If n is even, if n is even, then output is going to be 1. Okay. If n is odd, then output is going to be like A. Okay. So hope this is clear to you all. Next, coming to the some combined property of XOR and XNOR. Okay. So we'll see some combined property of XNOR and XOR. Suppose A XOR B is written over here. This can be further written as A bar XNOR B. Okay. This is going to be equal to A XNOR B bar. This is going to be equal to A bar XOR B bar. Hope means I will tell you how this is going to happen. If you take complement of whole this equation, complement of any variable, then the symbol is going to be replaced by XNOR. If it is XNOR, it is going to be replaced by XOR. If it is XOR, it is going to be replaced by XNOR. Okay. So this is the most important property that is used in many applications. Okay. So suppose like if A XOR B is written and whole complement is written like this. This can be further written as A bar XOR B or A XOR B bar or A XNOR B. Okay. This is how the complement is going to be distributed all over the XOR operation. Hope this is clear to you all. If you are having any query related to this concept, you can post it into the comment section. We will definitely help you out. Thank you. Thank you so much for watching.